guys, about Inca structural engineering, seismic technology. All that information was studied for a long time, for over 40 years. Really prestigious structural engineering universities and institutions from different countries came to Peru to study about that. Like the Osaka University. You know where is that? They came to Peru for sure, not in vain. Actually, before coming to Peru, they guided an interesting documentary, scientific information about the earthquake happened in Cusco City in the 60s. About the 80%, 80% of the colonial buildings built by the Spaniards just collapsed. That was a disaster in Cusco. Even the most important colonial building, the most sophisticated structural engineering Western technology built by Spaniards just collapsed, like the cathedral. The cathedral you see nowadays in Cusco main square, main plaza, that was just rebuilt. Even nowadays it's still restored. On the other hand, at the same earthquake, old Inca buildings, even the common buildings, still stay intact. That's the reason why the Japanese structural engineers decided to come to Peru in order to study about Inca structural engineering, seismic technology, and that. All these alcoves you see like this in every Inca building. Have you seen them? In temples, storages, residences. These have been used as the first point in order to get the flex in the building and hold 7.1 degrees in the Richter scale. And that's not only tremor. Man, that's just a big shock. That's an earthquake eventually. Optionally, secondary option, these alcoves can be used to store anything. However, to increase over 7.1 degrees in the Richter scale, you have to get its rigidity as well, not enough getting its flex. You have to combine, synchronizing both technologies at the same time. Have to get its rigidity. Have you seen two Inca buildings leaning 9 to 13 degrees, forming a trapezoidal shape? Not only in this alcove, windows, doorways, walls, you see? These are leaning 9 to 13 degrees. And that's to get its rigidity. Even all the buildings together are leaning 9 to 13 degrees, forming a trapezoidal shape. That's to get its rigidity. Through an example, we're going to catch easier. Who can help me? You, please. Stand up right here. Put together your feet. Right together. Now, be rigid. No balance, no moving. You are going to represent a solid building for a while here. About a horizontal earthquake wave force of just 0.2 newtons. So it would be enough just to get one of my finger forces to move the solid building. I'm going to pick up my weak finger. No balance, no moving, be rigid. Now, put hard your feet. Right. Be rigid again, no balance, no moving. Just the same. Another much stronger, an earthquake coming. Thanks a lot. Good guys. Good job. Alright. Got it? What do you mean anyway? Philip. Philip? Yeah. Have you seen Philip creating, making some extra forces by himself? Just to catch on its own balance. But Philip thinks making that, right? Otherwise, collapse. And what about structural buildings? Obviously, can't do that. An Incan structural engineer guide about that as well. So they decided to replace all these extra forces you've been making to get on your own balance, just extending these forces underneath. Means digging in every Inca building, everywhere. You're gonna see walls never end on this ground level, just continuing 1 more meter underground. And that's not yet the foundation of the building, because the foundation of the building in terms of structure never gonna come vertically. Otherwise, that would be just a column, and columns work in this way, right? So after that 1 meter underground, they just put the real foundation of the building. They made stone beams just to connect these underground walls. and that works really good. Of course, making that leaves a hole from this ground level to the foundation of the building. They just fill up on that hole with the gravel and sand. And you know, gravel and sand in terms of structures aren't so good seismic resistant material. What's wrong? By the way, do you know what the origin of the earthquakes in South America? Have you ever heard about subduction, tectonic plates? You know, the ocean plate, South American ocean plate called the Nazca plate, even nowadays is still pushing the above ground plate like this. That's the reason why you see really thick noise. However, at the time this ocean plate pushing the above ground plate, sliding down suddenly, and that is called subduction. And after that makes tectonic plates. The accommodation of this plate makes earthquake wave expansion. And that is split into two phases, the hypocenter and epicenter. The hypocenter shock is localized at about 40 kilometers underground. From there, the earthquake wave expanding just horizontal in different directions at 4 to 7 kilometers a second. You know what's the underground pressure? Not only above ground pressure, underground pressure as well. That means at the time this earthquake wave expanding, this is going to get less pressure, more and more, to get zero pressure. Stop for a moment, and after that just come back to the same spot in order to start the epicenter shock. From the epicenter shock, these earthquake waves keep expanding horizontal in different directions and upward at the same time. Of course, increasing from 7 to 15 kilometers a second, shock at the foundation of the building, something like this. Never stop, just go through. The earthquake wave shock impact is just energy, right? It's quite similar to the sound wave transmission needs molecules, atoms, quantum to keep expanding. Otherwise, no sound. And Incan structural engineers got about all these concepts as well. And relatively recently, humans understood about that when they were exploring the space. Before going to the space, the scientists couldn't catch on that. Because just in the space, there are some spots where there is nothing. And I'm talking about nothing means no molecules, no atoms, no quantum, just vacuum, is correct? We call that the vacuum. So if you're in the vacuum and you shout, even if you are close each other, you hear nothing. There's nothing to transmit the sound. Right? So scientists guide about this concept as well. That's the reason why they decided to put underground the gravel in sand just to absorb the shock before that's coming above ground. So coming above ground, not much. Just getting it flexed in this alcohol. So just synchronizing both technologies at the same time. And nowadays, the most sophisticated structural engineering seismic technology is copying Incan technology. In Tokyo, Japan, in San Francisco, California, everywhere. Not only protecting structural engineering technology as well. Okay, ahora sí, nos vamos hacia arriba y al fondo de nuevo. Would you like to go to the Condor Temple?
Yeah, let's do that. That's cool. It's cool. It's worth it. I know we're all lagging, but it's worth it.
Yeah, let's go.